Okay, so in this video, I'm going to be working on number 2, working on just doing the graphs of the basic trig functions and trying to show you a good process you can use for that and introduce some of the vocabulary related to it. So we're going to be working through what you need to do for problem number 3, which is to graph the 6 basic trig functions. So let's go ahead and work on that. I went ahead and included the 6 pages of graph paper. And so I'm just going to work through these and you should do the same. If you can print the graph paper and then use it, that would be great. All right, when you're thinking about how to graph y equals sine x, remember this is just a function and you need to get some ordered pairs plotted and get a sense of what's going to be happening. So what really works well is to think about the unit circle, okay? And to think about the quadrantal angles and what these key points on that unit circle, what the ordered pairs are for those key points. So like over here, you have the ordered pair 1, 0. Up here is 0, 1. Over here is -1, 0. And right here is 0, -1. All right, so when we're trying to graph the sine function, what really works well is to think about 5 key points, okay? And where they come from is, let me do it in red. Let me get this one. Kind of skinny in red. All right, so this would be 1, this would be 2, this would be 3, this would be 4, and then when we get back around here, that would be the 5th point. And remember how if you're on a unit circle, how the y-coordinate would give you the value, the y-coordinate of the ordered pair would give you the value of the sine function, okay? All right, so when you're doing these, notice that the x-axis is labeled with radians. That's because radians are actually real numbers, so they represent the length from here to here is pi over 2, okay? So you use radians when you're doing your graphs of trig functions. So what I'm going to be doing is I'm going to be looking at, well, what happens when x is 0? What happens when it's pi over 2? Okay, the 3rd point is at pi. The 4th point is at 3 pi over 2. And then the 5th point is at back around, but now back at 2 pi, okay? So when you're at 0, the value of the sine is 0, because that's the y-coordinate at 0 radians. When you're at pi over 2, so pi over 2 is up here. This is pi, this is 3 pi over 2, and then this spot is both 0 and 2 pi. So when you're at pi over 2, the value of the sine is 1. When you're at pi, the value of the sine is 0. 3 pi over 2, the sine is -1, and then 2 pi, the sine is 0 again. So we're going to plot those 5 key points. So we're going to talk about one of the essential properties of all trig functions. All right, so first let's get those plotted. So here's 0, 0. Here would be pi over 2, 1, pi 0, 3 pi over 2, -1, and then 2 pi 0. Now, one of the key features of trig functions in general is that they're what we call periodic. So they continue on and on in both directions following a similar pattern. So what you typically do is, what works really well is to plot these 5 key points and then just extend your graph. So we can see that this one would be back up at 1, or we could actually do it because 5 pi over 2, this would be 4 pi over 2, this would be 5 pi over 2. We can see we'd be back at 1. So we can just keep going around that circle to get these points. I can extend the other way, okay? So -pi over 2, well, that would bring me back. -pi over 2 would be right here. And so that's why I'd be down here at -1, okay? Or we can just look at the pattern and continue the pattern, okay? Now, when you're looking at what happens in between these, initially, it works well to think about splitting maybe the 0 to pi instead of just using pi over 2 to maybe using, splitting from 0 to pi into more break it down more, maybe looking at pi over 6 or pi over 3, or at least coming in here and looking at maybe pi over 4. And then over here at 3 pi over 4, just to notice something about that. You know, if I added those in to this table, so I don't have room there, but I just want you to think about it for a minute. We won't have to do this on all of them. But if I added in a couple more in between points, like pi over 4 and 3 pi over 4, okay, think about those. Okay, pi over 4 would be right here. Okay, and that ordered pair would be at pi over 4, the ordered pair you would have at pi over 4 would be square root of 2 over 2 for both cosine and sine. And so when you do that, square root of 2 divided by 2 turns out to be about 0.71. So you're not at half, you're not at 0.5 is what I'm trying to get at. This isn't going to be a straight line. It's going to kind of curve a little bit. You're going to be at like 0.71. So, and then 3 pi over 4 would also, 3 pi over 4 is over here. It would have the same sign. So it'd be kind of up here, more than halfway. So it's not going to be a straight line. Okay, so what the sine function does, and we could plot more points in between if we needed to, but it does something like this. It's hard for me to do this because I have my screen upright, but I need it that way to be able to access my keyboard when I need it. Okay. All right, and then continue the other direction. Okay, so if you have the sense of how it's curving, and then you know it's periodic, really just doing the 5 key points is all it takes. All right, if you want some in-betweens, just to kind of make sure you've got it, you can always go and find some more in-between values. But just by using those quadrantal angles, we really got a good sense of what the sine function looks like. All right, let's get all of these graphed, and then we'll go back, and I may do it in a second video. We'll go back and do some analysis of what we're seeing, and we'll introduce some vocabulary like period, okay, and amplitude, maybe look at domain and range. Well, let's go ahead and work on getting all 6 of these graphed to start with, okay? All right, so we can do the same for cosine. Okay, we can think about the unit circle and the coordinates of those points, those key points. Okay. Okay, and so we can think about, okay, what about when x is 0? What about when x is up there at pi over 2? What about pi, 3 pi over 2, and then 2 pi? Okay, so here we know that when we plug in for the input, when we plug in the angle, the 0 and the pi over 2, the output is actually the x coordinate of that ordered pair that you saw. Remember, that's a little tricky because we use a y here and you're thinking about y coordinate, but the y here is really the output to the cosine function. And so it's the value of the cosine at the angle. So the value of cosine at 0 is 1. At pi over 2, it's 0. At pi, it's -1. 3 pi over 2, it's back to 0. And 2 pi, it's at 1. Okay, so we're going to go and we're going to sketch those 5 points, okay, and see what we got. So there's 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and then 2 pi is at 1. And it's not a straight line. I don't feel like taking time to do the in-between, but it winds up curving, kind of going like this. And then curving around here, and then curving back up. Kind of has the same feel as the sine graph. It just does something a little differently right here, okay, when you get there, okay. Now you can just extend it, so you know you'd be back down here, then you'd be here, then you'd be back up here, and just extend it because trig functions are periodic. So that means they continue following that same pattern in both directions. Okay, so that's the basic cosine graph. Okay, all right, let's go ahead and look at cosecant. I did cosecant next because I want to show you what you can do for cosecant. Do you remember how cosecant is really the reciprocal of sine? Remember how cosecant is really equal to 1 over the sine? Okay. So when we're trying to do cosecant, okay, what we can do is think about those 5 key points that we had back with sine. So remember how we look at these 5 key points. Think about your unit circle to help you. It's always nice to draw one real quick. Only takes a second. Okay, and think about right here. Let me change that before I jump right into cosecant. Let's look at what sine x would be. Then we'll do what cosecant x would look like, okay? All right, so if we graphed, or if we plugged in 0 into the sine function, we know we'd be at 0, then 1, then back to 0, then -1, then back to 0, okay? Now, it really works well, and I asked you to do this when you graph it, is to graph the sine function first. Okay, so go ahead and get the sine functions graphed. Okay, so get that going. Because it really helps to kind of see the connection between the two. So this one right here is y equals sine x. All right, my real job was to do cosine x. I'm going to do that in red. I had you do one in pencil and one in pen. Whenever you graph cosecant, you typically graph the sine function first, and then you do the cosecant, making use of the picture you already have there for sine. Okay, because here's what you do to get the cosecant values. You can do 1 over your sine values. So see how we're going to have all these spots that are undefined because you can't divide by 0. And then we wind up having that, okay? So what happens is that 1 over 0, that these spots where your sine function equals 0, when you do 1 over that, it's undefined. Right there, you're going to need to put these dashed lines that represent vertical asymptotes. Okay, they're not actually points on the graph, they're actually spots where there are no points. Okay, and then what you notice is that spot is also a point on the cosecant graph. This spot is also a point on the cosecant graph. So would this be, so would this be, so would this be, okay? All right, and then if we came in to do a few in-between ones, so let me put in those pi over 4 and 3 pi over 4 just to give you a sense of what happens with those. Let me do it over here. Let me lower that just a bit. Let me write that down just a little bit lower. I always have to watch my time because I know it's hard for y'all to load the videos if I let them get too long. Okay. All right, what I wanted to do is extend a little bit and look at maybe pi over 4 and 3 pi over 4. Let you kind of see what happens as we look here and maybe even there and there. Okay, so 3 pi, 4 pi, 5 pi over 4. Okay, and this would be 6, that would be 7. Maybe look at those. Okay, those are related to the 45-degree angles, so you might remember the square root of 2 over 2. Okay, and I'm just going to do the decimal for it since I'm trying to graph. So this right here would be square root of 2 over 2, which equals about 0.71. And so if I did the cosecant, it would be 1 divided by 0.71. So it winds up being about 1.4, 1.41. Okay, 3 pi over 4 is also square root of 2 over 2. Okay, so that's also 0.71. So that would also be 1.41. So we can add that data. So when we're at pi over 4, okay, which is halfway here, 3 pi over 4, which is halfway there, the sine graph is at 0.71 on each of those, okay, 0.71, but then the cosecant is actually way up at 1.41, so it's actually up here, almost to 1.5. Okay, so it's kind of right in here. That should be over a little bit. Okay. It's about like that, okay? All right, what happens is it flips this way and then approaches the asymptote, getting closer and closer and closer, but never touching it. So it makes these little U's. Don't go past the asymptote. It never hits it or go through it. It just kind of does that. And see, what's going to happen here is 5 pi over 4 is also related to square root of 2 over 2, because pi over 4 is the reference angle for that, but it'll have a negative sign value. So it'll be negative 0.71. So this will be negative 1.41. So the same idea, but just negative 1.41. So about like right there. And then 7 pi over 4, same deal. Okay. And so what happens is your cosecant graph, it's like that spot's the same, but then it flips and gets closer and closer to those asymptotes. Never hits them. Asymptotes, these vertical asymptotes are never hit. You don't cross them at all. Okay. And then this is going to do something like that. And this is going to do something like that. And of course, it would continue if I showed more. It'd come back up. Okay. All right. So the red one is the y equals cosecant x. So see how that works? All right. Let's go ahead and look at the secant graph, because the same type of thing happens with it. Okay, so we're going to graph, we're going to graph cosine, or think about cosine, and then come in and do secant. Okay, we're going to look at the 5 key points. We won't spend quite the time we did like for a cosecant, since we already kind of got the gist of what happens. So let me get those 5 key points that are related to those quadrantal angles. Think about your unit circle. Okay, so you really can look at it and visualize it. Remember that cosine is the x coordinate of that ordered pair. So focus on the x coordinate of the ordered pair for the cosine. So we're going to have 1, then 0, then -1, then 0, then 1. When we do the secant, secant is 1 over cosine. So we'll take the reciprocal of each of these. And again, we're going to get some undefined values, but they're going to be in a different location. It's going to be undefined at different spots than the other one was. So what really works well is to go ahead and get your cosine graphed. And so you kind of see what's happening with cosine. And then you can get that one graphed pretty quickly. Okay, so cosine's going to look like this. Okay. All right, I could continue. All right, then once you do cosine, you come back, and I think what works good is to look at these undefined places and see what the location was for those. Notice it's related to where the graph of cosine crosses the x-axis. That's when you do the reciprocal, that's going to give you a value that's undefined. And so go ahead and put in those vertical asymptotes there. Okay, then notice that at 0, this points on the secant graph. And then at pi, this point's also on secant. This point's also on secant. And then the secant graph does kind of like cosecant. It just flips the other way and makes these U's. Kind of see how that works? So you can do a quick sketch of that. Oops, that didn't look very good. Okay, this one's going to be down here. All right, and so that's the gist of it. So this right here, that's the graph of y equals secant x, and we did it by first thinking about y equals cosine of x, and then just doing the reciprocal of those 5 key values. But see how even cosecant and secant were periodic? They kept repeating as you went to the right and to the left. All right, I got 2 more I want to do in this video, and then I think I'll split this into 2 and do a video just on things like domain and range and period and that sort of thing. Okay. All right, let's look at tangent. Okay, draw your unit circle. Get those ordered pairs labeled correctly. Okay. And then let's go ahead and see what happens. All right. Now with this one, it's going to be kind of interesting. So you don't know this yet because it's the first time you've seen tangent. All right. So if I look at 0, I'm going to space this out a little bit more and write a little smaller. If I look at 0 and pi over 2, pi, and 3 pi over 2, and then 2 pi again. Let's see what happens. So tangent, remember, is sine over cosine. So that means we can still use those ordered pairs, but we're just going to be doing a fraction. So the value of tangent when x is 0, the tangent would be 1, would be opposite. That would be the 0 over the 1. So that would be 0. When we do pi over 2, it's going to be 1 over 0, which is going to be undefined. When we do pi over here, we're going to be at 0 over -1, which is also 0. 3 pi over 2 is -1, but the 0 is on the bottom, so it's undefined. And then with 2 pi, it's 0 over 1, so we're back at 0. Okay, so we're going to need a little more information, you'll see in a minute, because when I plot those ordered pairs for tangent, I have a 0, got this spot where it's undefined, that's going to wind up being an asymptote. And then at pi, I'm back at 0. 3 pi over 2, it's undefined. 2 pi is back at 0. So that's going to continue. This will be an asymptote. Okay, over here, I'm going to have an asymptote. See where the asymptotes are going to be? Okay. But having only that information, I can't really tell what the tangent really does. So you really need to get at least one more spot in there. So I like to do just these spots halfway between, okay? So that's at pi over 4, 3 pi over 4, okay, 5 pi over 4, and 7 pi over 4. So let's squeeze those in and see what happens, okay? Really, if we just get the first couple of them, you'll see what's going on. All right, so when I look at pi over 4, remember how that is going to be square root of 2 over 2, square root of 2 over 2, because that's the 45-degree angle, or the pi over 4. So tangent is the y-coordinate over the x-coordinate, and see how that's going to equal 1. Okay, when you're over here, remember how this spot right here would have, not go so far on that. This spot right here would also have square root of 2 over 2, but it would be negative square root of 2 over 2, and then positive square root of 2 over 2. So you're going to get, on that, you're going to get a -1. Okay? But when you're here, both coordinates are negative. Okay? And so when you do that one for tangent, you're going to be back at a +1. But when you're over here, it's going to be positive square root of 2 over 2, and then the y-coordinate is going to be negative. So you'll have a -1. So it kind of fluctuates between 1 and -1. So pi over 4, which is right here, is at 1. Okay. And then let's look here. 3 pi over 4, okay, that would be about right there, is at -1. 5 pi over 4, which is halfway between these two, it is back at +1. Okay. And then 7 pi over 4, which is here, would be back down at -1. I think you'd see it best looking in this area. So what's going to happen here, and we could graph more to see it. You could find some more in between as it comes in and curves there and then flips around and does that. Has this look to it. Okay. All right. So what would happen is if I went and I wanted to find out what the value would be over here at -pi over 4, it's going to be this way, but it's going to be the same as what I had for 7 pi over 4. Those are coterminal angles. So it'll be down here at -1 also. All right, and so I wind up coming in like this and then going like that again. All right, and if I had extended this one, it would be back up at 1. So this happens again. So I keep getting that same look. That in between those two is going to be 1 and -1. See it? And then it approaches the asymptotes. So that's y equals tan x. All right, and then cotangent, oops, that moved. Let me see if I can get that back. Okay, it kind of slipped a little bit when I did that, so I'm going to try to leave it now. All right, when I do cotangent, for that one, remember how that one's the cosine x divided by sine x? Okay. Or you could do it as the reciprocal of tangent. You can treat it either way. Okay. Or think of it as 1 over tan x, however you want to think about it. Okay. And so if we looked at like what we did with tangent, if we looked at the values we did there, okay, to start with, we could look at those same ones, leave a little room though so you can fill in those in between. Okay. And then you might want to look at those in between pi over 4s. At least the first time we do it. Don't forget the quadrantal angles can help, or go back to tangent if you want and look at the tangent. Okay. And so when we do this, we're going to do cosine divided by sine, pi over 2, cosine divided by sine, pi, -1 divided by 0, 3 pi over 2, 0 divided by -1, and then 2 pi would be back around where 0 was, and it would be 1 divided by 0. So we're going to have undefined everywhere we divided by 0. Okay, we're going to have 0 in these other spots. And if that's all we did, it's kind of like what happens on the tangent one. It's almost like I need just a little more information the first time I do it so I get a sense of what it looks like. So the undefined spots, that's where you're going to be having these vertical asymptotes. So it happens at 0, and then at pi, and then at 2 pi, and at -pi, it would happen. Okay, and then I'm going to have my pi over 2 is going to hit right there. 3 pi over 2 is right here. So would 5 pi over 2. So would -pi over 2. So would -3 pi over 2. And so what you need to do is just get a little more information to know what happens for the rest of it. You're expecting it to look a lot like tangent, and it will. Well, let's see what happens when we go to this pi over 4. So pi over 4. Okay, remember how that's square root of 2 over 2, and then just the variations of that in terms of positives and negatives. Okay, so pi over 4 is going to turn out to be 1. Okay, 3 pi over 4, that's going to be a negative x and a positive y, and so it's going to be -1. 5 pi over 4 here is going to be a negative, so that's going to be back to +1. And then 7 pi over 4 is positive, negative, and so that's going to be a -1. And so then we'll look at those. So pi over 4 is going to be at 1. And then 3 pi over 4 is at -1. 5 pi over 4 is at 1. And then 7 pi over 4 is at -1. So this is kind of like the tangent one, but it's going to come in like so. And then it inflects, curves, and does that. Comes in like so. I'm trying to hit that spot. Okay, it goes through there and then goes down. And that would be true on all of these. Comes in. Okay, so I like to just kind of put those points where I know it's going to wind up being on the in-between parts, so I can help myself get a decent graph. Okay. All right, so I'm going to stop my video on this part right here, and then in the next video, I'll come back and we'll analyze these. We'll talk about domain and range, period and amplitude, that sort of thing.